In this video, we will discuss my personal PhD project, which explores the application range of natural language processing in literary historical contexts. First, we will introduce the CLS Infra project, which funded and inspired the theoretical underpinnings of my work. Then we will get into the research questions of my thesis and how we tested a range of methodological approaches on literary historical datasets and also how we aim to move forward from here. So the Computational Literary Studies Infrastructure Project, or CLS Infra for short, is a 4-year partnership to build a shared resource of high-quality data, tools and knowledge to aid new approaches to studying literature in the digital age. So rather than focusing on creating new models or tools, this project really seeks to build a strong infrastructure by having a look at what the CLS community needs and how we can link up already existing tools to cater to these needs, because there are already quite a lot out there. So the project is made up of 8 working packages. Some focus on the societal challenges and others focus on data or the technical challenges. And we at the Ghent Center for Digital Humanities are responsible for methodology and the application of natural language processing. So based on the CLS Infra project as a starting point, I formulated 2 main research questions which then serve as axes to start from, as starting points. So firstly, as discussed in the previous video, we will dive into the theory and explore why the application of natural language processing to these literary historical datasets is such a challenge. Then secondly, we will build upon this knowledge to experiment with and evaluate some cutting-edge NLP techniques for information extraction on literary historical data. In this video, we will discuss 2 things. So how we evaluated an aspect-based sentiment analysis approach, as well as a range of open weights generative models for named entity recognition. What we mainly want to explore here is which techniques are out there, what their pitfalls and advantages are in this context, and then last but not least, how we can translate our dataset and workflows to the public to foster reuse and improvements. So a quick recap of a first experiment that we have done. There we explored the use of aspect-based sentiment analysis systems on a literary historical dataset of travel literature. So usually, as you may or may not know, sentiment analysis, so giving a sentence or a paragraph a valence in positive or negative, is done on the level of, as I said, the sentence, the paragraph or the document. But in a highly subjective context, such as literary historical text, this technique is rightfully so often deemed critically regarded in CLS because it is often deemed not fine-grained enough. However, it is also possible to conduct a sentiment analysis on the level of the aspect, so on the level of the entity, a technique which has not been thoroughly explored in digital humanities. Let's just give you an example. So, if we have a sentence, Rome is a beautiful city, but the Trevi Fountain was disappointing, if we would give this whole sentence a sentiment score, that would be that would not really give a good overview of what the sentiment valence of this sentence is. But with aspect-based sentiment analysis, we can connect beautiful city, for example, to Rome, which would then be a positive valence, and disappointing to the Trevi Fountain, which would then be a negative valence. So that is more fine-grained and more applicable for literary historical research contexts. So to do this, as a first step, of course, we created an annotated dataset of literary historical travel literature from the 18th to the 20th century for this purpose in a couple of languages, namely English, French, German, and Dutch. The aspects that we annotated pertain to the environment of the traveler. So they had to do, as you can see on the image, with fauna, flora, weather, person, location, etc. We then annotated these entities by connecting the entities, the aspects, to a sentimental expression in the sentence, so in the text. We did this on a 1.5 scale, so the score 1 would then mean that the sentence is very negative or the aspect is very negative, and 5 meaning that the aspect is very positive. Then we use this dataset to compare 3 methods, a rule-based one, where we used the parts of speech taggers in an NLP package called spaCy for noun and opinion word extraction, and then also SentiGNet to give a valence to opinion words. Next to that, we also made a discriminative AI system where we trained a sequence tagger using FLAIR for the aspect extraction, using BERT and MacBERT embeddings, which the latter are trained on historical English, so we thought it would be interesting to compare the two. To tackle the sentiment analysis task then, BERT and MacBERT models were fine-tuned on the gold standard aspects and then served as input for a range of classical machine learning classifiers. Then lastly, we tested a generative AI system where we prompted the Mixtral Instruct model for aspect extraction and sentiment analysis, respectively. At last, we then report on the method. So we report on the process, the data collection, the annotation process, and the models, and also give a quantitative evaluation where we'll calculate the evaluation metrics such as F1 and a qualitative evaluation, where we assess its usability and fitness for computational literary studies. So as expected, we found that our discriminative systems rendered the most precise results when compared to our gold standard annotations, and that changing the 1 to 5 point scale, so very negative to very positive, to a 1.3 point scale, so positive, neutral, negative, gave the model less options and gave us better results. At a later stage, we used this approach, so the models that we have created, the workflows that we created, in a theory-first setting by applying our discriminative model to uncover sentiments, so positive or negative, in comments that were associated with 8 aspects of fanfiction stories of Greek mythology. However, the main thing that this research did is really inspire us to dig deeper in the possibilities of using generative large language models as a gray box method in CLS. So another research paper that we made is the evaluation of generative AI for named entity recognition using the same datasets. Due to the advent of these generative large language models as information extractors, we really wanted to test these models in the literary historical domain. So through the GPT-4All tool suite, which is a tool suite which provides quantized versions, so comprised versions, of a wide range of instruct models, we tested a couple of models for extracting fauna and flora from our travel literature. And then we conducted a qualitative and a quantitative evaluation on the results. Basically, applying generative AI as an information extractor and then seeing what happens. By using stratified subsets of 100 samples across the languages that are present were French, Dutch, German, and English, and the centuries, so from the 18th to the 20th century in our dataset, we tested 5 different prompts which incrementally become more complex. So we start out with a very simple task description, just telling the model what we wanted to look at, so that we wanted to extract fauna and flora from our text. Then we add a persona. Then we add an annotation guide, so giving the model a bit more explanations on what we mean when we say fauna and flora. Then we add some context information, so some metadata, the name of the author, and for example, the title of the book where the sentence comes from. And then we also give the model some examples from the training data. After that, we conduct a qualitative evaluation. So what kind of mistakes do we see and how could the mistakes be happening? And a quantitative evaluation, so where we calculate F1 strict, where the label and the string need to overlap for an entity to be considered correct, and F1 entity type, where the label needs to overlap, but the string can partially overlap for an entity to be considered correct. So the quantitative evaluation, as you can see on in the table, which shows a lot of numbers, shows us that the Llama model, which we have evaluated, gave us the best results across the board, which makes sense because this is one of the later models, one of the newer models. The models struggled most with French and Dutch. We got the best results, as was to be expected, for English and German, which is probably because these languages are more represented in the training data. Boundary matching is quite challenging, and we saw that the models were better at predicting fauna than flora. However, there is no silver bullet prompt structure. In general, we did get some impressive results with little effort, but it is clear that we still need to see which approaches work best for each goal that we set. So based on our qualitative evaluation, we noted that all models showed a tendency to adapt entities before extraction. OCR errors were sometimes automatically corrected, and entities were often also translated to a modern version of the word or to an English version of the word. As you can see in the table, for example, where we show a sentence where watermeloenen, for example, the word for watermelons in Dutch was extracted as watermelonen, so the spelling was adapted or anglified. The model sometimes also produced nonsensical hallucinations. Despite the small size of our case study, we also noted bias, and this was quite notable in our results, in the sense that all models across all languages showed a tendency to categorize names of indigenous populations which were present in the text as fauna. And we saw this with the word Kaffers, for example, which was used in the source text set in South African colonial history to refer to the Xhosa people, so an ethnic group native to the country, as well as with the N-word, for example. We ran a small-scale experiment where we swapped out these words for neutral denominations for person, and then we didn't see this phenomenon occurring. So some research that is still underway, building further upon our findings on generative AI, our next step is the creation of a retrieval augmented generation approach for relation extraction to automatically extract relationships between correspondents present in Guido Gezelle's letters. And Guido Gezelle is a renowned Flemish poet and writer from the 19th century. However, of course, there is clearly still a lot of work to be done. The NLP landscape is super vast, as well as, of course, the DH landscape. And in doing this research, we aim to start experimenting with the application range of AI in literary studies and actively involve historians and literary scholars in the red-hot debate surrounding AI.